Okay, just now we have learned how to solve the BVP without derivative, with the boundary condition without derivative. But now we want to solve the BVP, but this time the boundary condition we have the derivative. For example, just now the derivative at ya equal to alpha, yb equal to beta. Okay, just now without the derivative, directly, but this time with the derivative, maybe we have one derivative, or maybe the derivative at xn, or maybe both. It depends on the condition given. Right. For example, this one. Okay, we have ya, y prime, and also y prime here. Depends on the condition. Right. So first, Neumann. If Neumann, this Neumann means both condition we have the derivative. For example, here y1, y at x known, and also y prime at x, and we have the derivative. So if we have the derivative, so we call it as the Neumann boundary condition. Okay, so we have x, y prime, blah blah. Okay, and then by using the finite difference method, show the above question can be written as follow. Hence, approximate the solution for the following boundary value problem. Okay, right. So we have x, y, okay. Right. Okay, so first maybe we need to use the center difference to find the formula, discretized formula. Okay, maybe the first step we divide by x. For example, we have y prime, so 1 over x. Zero. Okay, and then by using the centered formula, okay, and then multiply with the h squared, so we have zero. Okay, y minus 1. Okay, one, h is 0.5, 0.25 over xi. H, okay. Negative. yi negative 1.75. Okay. So yi negative 2 plus squared. I and the last one 1 plus 0.25. Zero. 1 minus 1 plus, plus minus plus, plus positive negative positive. Okay, right. So we have this one. Okay, right. So the question number 2. So we have to construct a timeline. With our x naught equal to 1, x1 equal to h is 0.5, so 1.5 oh, until x2. Okay, until x2. Okay, now, so from the boundary condition given, it is in derivative. Just now what we have done is Dirichlet without derivative. Obviously, without derivative, we will have the answer for the y naught, yx naught, and also yxn. But if the boundary condition with derivative, we cannot get the answer. We cannot get the answer for the y naught and also yxn because this one in derivative. Okay. Okay, but what we have to do is, so we have y prime 1 equal to 0.5. So y prime x naught equal to 0.5. So y prime naught equal to 0.5. Okay, alright. So by using the centered difference, okay, we have y prime. Okay, y prime is equal to yi plus 1 minus yi minus 1 over 2h. So this is the formula for the centered difference. But if we have y naught, this one y0. So y prime 0 equal to, this one is I. Obviously our I. So I0, so y1 minus y negative 1 over 2h. Equal to 0.5. Okay. Therefore, our y negative 1 equal to y1 minus 0.5. Okay. So this is from the first boundary condition, and from the second boundary condition, second we have y prime 2 equal to 0. So x2 is x here, 2 is x2. So y prime 2 equal to 0. Therefore, by using the centered difference, so 2i equal to 2, so 3 minus y1 over 2h equal to 0. Therefore, y3 will be equal to y1. So this is from our second boundary condition. Okay, right. Okay. So now our aim is we need to find what is the value for y0, y1 and also y2 by using the formula that we have discussed before. Okay, now from this condition, from this equation, so we want to find y0. Okay, y0, y0. Okay, so you ask yourself, let's say if you let your I equal to 0, so here you will need to find y negative 1. But it is not a problem because of from the boundary condition, we have the value at y negative 1. That's why for this case, it's okay. Okay, if you start your I is equal to 0. Okay, that's why you always have to ask yourself, what is the value of I that you need to start? For this case, I equal to 0 because if I equal to 0, y negative 1, but we have the condition, from the condition we have the y negative 1. Okay. X not equal to zero, and we have the condition y negative 1 equal to y1 minus 0.5. Your first question. Okay, right, so continue. For I equal to 1, x1 is equal to 1.5. And the last one, because our focus we want to find y0, y1, y2, so 3 value of y. So we need to value three equations. X2 2. Zero. Okay, but from the timeline we don't have the value for from the condition y3 is equal to y1. y1. So 2y1 minus condition. Okay, alright. So back to the question. The question, hence approximate the solution for the following BVP. Okay, so for this case, if the question asks you just to approximate the answer, so you can use your calculator. But sometimes for this question, you need to apply what you have learned in chapter 2. Okay, how to solve the linear system. We have several methods like Gauss-Seidel, Jacobi, Thomas, and all that formula that you have learned in chapter 2. Sometimes to solve this question, you need to apply what we have learned in chapter 2. But for this case, because of the question does not mention anything, just approximate the answer. So you can just apply, just use your calculator. So we have 3 unknown. This is my answer. 0.1666, 0.333, and the last one is 0.3809. Okay, alright. So by using the calculator, this is my answer. My y naught is equal to, just give your answer in 4 decimal places. So this is your answer from the calculator. Okay. Okay, I repeat again. Let's say to solve the BVP, it depends on the condition given. Just now, if we have Dirichlet boundary condition, that means the condition without derivative. So you will have the answer for the y naught and also yxn. Okay, the first one for Dirichlet, Dirichlet, you will have the answer for the y naught and also yn. Okay, but for the Neumann means you have the both derivative at both condition. Okay, so for the Neumann, you will not the answer for the y naught and also yxn will not be given because we have the y derivative too. Hopefully you can get what I try to explain lah. Okay, right.